introduce it and show you how to use it and some other stuff. Okay, so what are we going to talk about? We're going to give a short overview of what Appium is and how this project started. We'll go over the setup process, which is a painful point for many. We'll see how to automate native application, WebView application, and even the new Android wearables. We're also going to go over the difference between automation and testing, and specifically we're going to get into visual testing, why you should do it and how you should do it. By the way, you can raise your hands if you're not using Appium. Anyone who's not using Appium, please raise your hands using the raise hand bar. Okay. Okay. So I see there are quite a few, so I'll go over the introduction in a way that will hopefully give you a shortcut to installing it. So, okay, so Appium Overview. First of all, what is Appium? For those of you who heard, Appium is an open source test automation framework for use with native and hybrid mobile applications. This means basically that you can automate the standard native iOS, the Objective-C applications, and the Android Java applications, as well as the WebView applications, such as the PhoneGap. Well, this basically shows that Appium gained a lot of momentum in the past year. Appium actually started from a work of Dan Quayler and Jason Huggins, and they started it from scratch in 2013. So it's relatively a new product, but it's gained a lot of momentum, and now it's in use like many other automation frameworks, such as Robotium or Calabash. Okay, so I've prepared a short demo, so you can see exactly what do I mean when I say mobile automation. I'll show with you my other screen, so please bear with me. Okay, so the first thing we're going to do, and I'll show you how to do this later, don't worry, is to start an Appium server. And now I'm going to use an Android emulator, a Genymotion emulator, by the way, which is the standard emulator with a VirtualBox wrapped around it, so it's quite faster than the one given with the Android SDK. Okay, so let's go. I'll go over the code later. No need to worry about it. The only thing I want you to see is how does an automation with Appium looks like. So I'm running this script that I wrote, and it's gonna start an application on this emulator, as you can see. This is a notes application. It's going to write a couple of notes. The famous Monty Python quote. And another note. No, sorry. It stopped for a moment. Anyways, we'll go over the code soon enough. Just wanted you to see what an automation looks like. Okay, so let's go back to our presentation. Okay, so automating with Appium. Appium basically was created with 4 design goals in mind. The main goal is that you test the same application that you submit to the marketplace. This means that you don't have to recompile your application with any automation code. It runs just as if you would submit it to the marketplace, just like it's written. You want to write tests in any language, and you want to use a standard automation specification or API, and it's open source. So, just a moment. By the way, the device that I've showed you before was an emulator, not a real device. Appium runs on, can automate applications on real devices just like emulators. If I did it on a real device, you wouldn't be able to see it on my screen. So that's why I used an emulator. Okay. So basically, with all those 4 design goals, the most appropriate standard at the time was WebDriver. WebDriver is a standard for automating browsers, for automating web. And what Appium actually does is take that standard and just interpret it in a way that's appropriate for mobile. Okay, so how does it work? You have your test code, which is what you see on the left side. And the test code communicates with Appium using the standard Selenium, the wire protocol, which is those 2 arrows that you see. Appium translates it to commands to the device, and the device runs the application. Now, Appium uses the standard automation infrastructure for each platform. So for Android, it uses UI Automator, and for iOS, it uses Instruments. You can write Appium tests in all of the most popular languages, such as the ones you see here. It's open source, so it's Apache license. And the supported platforms are currently Android and iOS, which are the most popular, and also Firefox, which comes with an automation framework that's already built in Firefox OS. Just a moment. If anyone would like to ask a question, you can just write it in the questions part, and I would be happy to answer it, by the way. Okay, so let's continue. This is how Appium automates Android, which is basically what I've said before. It uses the UI Automator infrastructure. It basically loads an automation jar file into the device, and that jar file is a server waiting for Appium commands. And Appium, whichever command you send to Appium, Appium forwards it to that server. For iOS, it's similar. The difference is that it uses Instruments, which is iOS's automation infrastructure. It also has some kind of a workaround, so it can work with iOS. It sends commands to the command line, and Instruments pick the commands from there, but it's really, there's no point in getting into it right now. It works basically the same. Okay, so Appium has limitations, of course. These limitations are most visible on iOS. Instruments, which, as you recall, is the automation infrastructure that Apple provides for iPhones. Instruments can only run as a singleton, meaning it can only run once on a Mac computer. So you can't parallel test multiple devices on the same computer. You can test them using a grid, for example. You can connect few devices to a number of computers, and you can control them from a single computer, but for a single computer, it can only be connected to a single device at one time. It's also a relatively new product, so it has documentation issues. It's not bad, but they can improve, and they do. Okay, just a moment. Yes, there are questions. Okay, so the first question my question was related to the machine on which the emulator was started. Is it a real device or a virtual one, and what was the OS version? Okay, so the demo that I've showed before, and I will show it again, and don't worry, was an emulator for Android 4.4. It was an Nexus 5 emulator. It's basically the same as the standard emulator that comes with Android. It's called Genymotion. It's free for personal use, and they also have a commercial version. It's just a faster version of the emulator. Setting up, the next question was how to set up Appium on Windows 7. So I will get into how to set up Appium very soon. If there's a difference between Mac or Windows, I will definitely discuss and mention it. So bear with me. Okay, so the future of Appium, basically it's already becoming a present. Appium basically aspires to be part of the Selenium 3 protocol using the mobile JSON wire protocol. It's a joint effort of Appium, of Facebook, eBay. It's supposed to be this standard for automating mobile. They plan on supporting additional platforms and adding advanced gestures and client libraries, which now exist. I will show them too in the demo. Okay, so following your questions regarding the setup process. First of all, requirements. For Android, Appium is only available for API version 17 and above. And for iOS, you have to have OS 6 10.7 and Xcode 4.6.3 at least. If you have lower versions than this, then Appium won't be compatible and you probably would run into errors. Firefox OS is currently available only as a simulator. Okay, so installing Appium. Appium is available in two forms. Okay, one of them is an actual application, a front-end, a client front-end. I'll actually show it to you right now. Just a moment. Okay. This is the Appium application. You can download it from the Appium website. It's available for Windows and Mac. This form is not available for Linux, unfortunately. The other version of Appium, the other form of Appium, is a command line form. It's a server which you install. I will, again, bear with me. This is actually what you see here is the command line server. You can install it using this command, the npm install command at the bottom. And after you install it, it's just a general command line tool. You can start it and stop it. We'll even do that right now, just so you see. Okay, this is how you start Appium once it's installed as a command line server. You just write Appium. Full reset is one of the options. If you want to know about it, I'll explain later. You just run it, and that's it. Appium is run. Okay, so we'll get back to the presentation. The command line option is available for all platforms. Since it's a node model, basically, you can install it on Mac, Windows, and Linux. Okay, client libraries. After you have the Appium server, you need to write test code that communicates with it. So you can do it, like I said, in all of the popular languages, programming languages. For example, you can do it in Java, which is all of my demos right now will be in Java. If you're using Maven, this is how you add your the Appium client libraries to Java. If you're using Python, there's another example. You can do it to Ruby and C# as well. I've posted also a link to the Appium documentation where you can find how to download the client libraries for your programming languages. Okay. Sorry. Okay. The second thing and the most important thing when setting up Appium is called the desired capabilities. These are basically a set of definitions that you write in your code that tell the Appium server what exactly is that you are trying to run. So if we look at the definitions at the top, these are definitions for a native Android application. So you can see that the platform name, the platform that I want to run is Android platform. The version of the Android platform, the device name. The device name, by the way, is I believe this is optional. It doesn't really matter what you write in there. The app package, and app activity are basically the way you tell Appium which application you want to run and what is the entry point for that application. The UDID is an identifier of the device. So, for example, if you run multiple devices, which I will again show very soon, you tell the Appium you're communicating with which device should it automate. Okay, just a moment. I have another question. Oh, okay. The question was about the release keyword in the dependency. This basically means it tells Maven download the latest version. So every time the version updates, I think Maven checks it like once a day. So you get the most recent version. Okay. The second example of desired capabilities is for automating a WebView application. So you can see the differences between the first example and the second. The most important of which is the automation name, which it's written as Scalable. It's another another engine that Appium uses to automate WebView applications. And the second important difference is that app package and app activity are without that dash in the middle. This is because the Scalable engine has a backward compatibility kind of definition, so you have to use that phrase instead of the dash one. Okay. Any questions so far? Okay, so we have a question, a few of them actually. Is there any other configuration needed other than just installing Appium before it can talk to an application? Well, yes. The configuration that you need to install is you need to have the automation environment of the platform that you want to automate. So for, like I said, for iOS, for example, you need Xcode and Xcode command line tools. And for Android, you need the Android SDK and some kind of an emulator or a real device. What's important to understand is that Appium uses the automation infrastructure provided by the vendor, which means it uses the infrastructure provided by either Google or Apple. It doesn't have its own automation infrastructure. It just utilizes it. So once you have your emulator running, Appium should be able to run without any further installation. Another question was, WebView means Cordova or PhoneGap? Yes, when I say WebView, I mean Cordova applications. Could you show a summary of the capabilities which should be used by iOS applications or web views or browsers? I don't have them in the presentation, but I will definitely publish them after the webinar, so there shouldn't be a problem. Okay, I'll continue with the rest of the questions a bit later. So we'll go over the other parts of the presentation. Okay, so once you have Appium installed and you have the client libraries that you can use to communicate them, you need to understand how to work with Appium. So the most important thing when automating with Selenium and therefore Appium, as we said, Appium uses the Selenium standard for automation, is the finding of elements, meaning you want to find a button, for example, on the application screen, or you want to write a text in a specific input. For that, you need to know how to find these elements so you can automate them. These are the find type of commands. Well, there are four main ways in which you can find an element on your application using the Appium standard. The first one is by name. I will show this again very soon. By name means that you would either look for a text written on the element, for example, a text on a button or a text on a note or a text element or whatever, or a text that is defined as the accessibility identifier. Many people don't know this, but you can define an accessibility identifier, kind of a tooltip for elements in your application, for example, to help the deaf to navigate through your application. So if you define this accessibility identifier, you can find this element using the name method and search for that identifier. The other way is class name, which is basically the type of the element. Okay, here you can see an example for an edit text box. This is how you look for an edit. This is how you find an edit text box in Android. And the other way is XPath. You can literally code a path that points to your element, to the element that you want to find or click or use, and you can do that with XPath. There's an additional way using platform-specific API, for example, find element by Android UI Automator, which lets you write a UI Automator string and find the element using that. This is possible, again, since Appium is using the vendor automation infrastructure, so Google's automation infrastructure or Apple's. Okay, so just a moment, let's go over a couple of questions. Do we just need the packaged app to instrument it on the emulator? Yes. For Android, you need the packaged application, and that would be enough. More than that, with Android, you can automate applications already on the device, so you don't really need the APK. You just need to know what's the activity and package name. For iOS, you must have the app file. You can automate just anything that's on the device. So this is an example, what you see here, for finding an element by name. This is actually how I do it in the code. The red circle that you see on the bottom right part, which wraps the content description part. Content description is the accessibility identifier for Android applications. So as you can see, there's the identifier there is a new note. And when I do find element and I search for by name, as you can see in the top part of the screen, if I search for new note, then it will find that element. By the way, the tool that you're seeing right here is called a UI Automator Viewer. It's an Android automation. It's part of the Android SDK. It has nothing to do with Appium. And you can, once you download the Android SDK, you actually have it on your computer. So, for example, let me just so you'll believe me. This is UI Automator Viewer, and it popped up on the second screen. But this is it. This is that tool I was talking about. So, for example, I can take a screenshot. This gives me the list of currently available devices. I'll just choose one so you can see it. Okay, so you can see the different elements on the screen. You can see if they have a content description, you would see it. For example, what you see here. And you can see the class name. We said that you can search for an element by using the class name. This is the class name that you use. For iOS, you have the Appium Inspector, which is part of the Appium application, the actual UI application. But I will not go into it right now. Anyways, we'll leave that alone, just for demonstration purposes. Go back to the presentation. Okay, so there was a question regarding the UI Automator. Is it the same as the XPath add-in to find XPath? I'm not sure exactly what the XPath add-in is, but you can definitely use the UI Automator in order to find an element using the XPath. For example, if you look at the top right part of the UI Automator window, where there's all the frame layout and linear layout, this is the path that you're going to write using the XPath. I will show that in a second. Okay, so we've been through the find by name. Like we said, it's the content description on Android. It's the accessibility identifier on iOS. You can search for an element by class name, which is what I've shown you a second ago. As you can see, the red circle around the class name. If you search by that, that's the type of the element. Usually, you would use that to find a list of elements of a specific type, or if you have just one type of element that you know it's on the screen right now, you can use that to find that specific element. There's an example on how to use find by class name at the top here. You can see it, and that's class name. An example of finding by XPath. As you can see, you've asked about the XPath add-in. This is an example of finding by XPath using the layout given by the UI Automator. Okay, so these are the three main methods for finding elements. There is also a platform-specific method for finding elements by Accessibility ID or by Android UI Automator, which receives a string, UI Automator string. Those of you who are familiar with the specific infrastructure, automation infrastructure of each of the vendors, you can definitely use that. If not, you can use the standard Appium methods that I've shown before. So the question was, is the UI Automator only for Mac and Windows? I'm not sure about it. I think it should run on Linux as well. As far as I know, it's a Java application, so you should be able to run it on Linux. So I think it should be available. Okay, so let's do some automation. Okay, so we'll go to a few demos. Bear with me for a second. We'll share my other screen. Okay. So the standard automation, standard example of automation we've seen. It was the first demo that I've shown you. What I'm going to do, I'm going to show you another demo, this time of two devices separately. By the way, for those of you who asked, this is Genymotion. This is the wrapper for Android emulators. It's, like I said, basically it's standard emulator, but it's just much faster. So I will start a Nexus device, and this is the Nexus device I've started, and a Galaxy 5 emulator. Okay. So as you can see, they loaded very fast if you're familiar with the Android emulators, or relatively fast. And what we're going to do is we're going to run an Appium application. Okay, you know what? First, since you had a lot of questions about the desired capabilities and code, just so you'll see, the first code that I ran, the first demo, this is basically the code. That's it. The parts that make the code are basically you create an Appium driver, which is a standard web driver for those of you who are familiar with Selenium. You give it the Appium address, which is currently my local host. Appium runs on my local host at port 4723. You give it the desired capabilities, which is what we talked about before. And once you have the driver, this is your main interface for finding elements and automating your application. So what I did there, I basically I added a function, a static function for creating a node, just so it would be clear, which I passed the driver as an argument. I created single node, another node, and then removed the third one. And how do we do that? If we'll go to these are the functions. I wanted to use as many methods as I can for finding elements. These are the functions we talked about. The first thing I do is find an element. Okay, let's go first for create node. The first thing that I do is find the element that has the accessibility identifier of new node. If you remember from the presentation, we'll see, you can see it here, I think. This is the element, which has a new node accessibility identifier. Okay, and once I found it, I just click on it. This is a standard WebDriver command, so it's a standard Appium command. After I clicked on it, I have the I got the new node screen opened up. In that screen, I found the text box to which I can write using the class name find method, and then I wrote the text that I received as a parameter. And the last thing that I did was finding the save button, which is the long X path that you see here. And that's it. That's how you create a node in the node list application. The remove node or clear node is basically the same. What I did, I searched for a node with the text I was given. Remember that I said that name searches either by accessibility ID or by the text that's written, that's labeling the element. So this is how I use it. And after I found that specific node, I clicked on it, I found the text box and cleared it, and then saved it again. Notice that this time I searched for the save button in a much easier way. I just used the accessibility identifier. So basically, that was the first demo. I saw that we have a couple of questions. So, are all those devices added in Genymotion by default? Okay, so the devices that I've shown before, which I think is just a moment. Those are devices that are available in Genymotion. They're not there by default. You kind of download them, but you don't have to create them yourself. As I said, they're just virtual machines in VirtualBox. So if we go to a VirtualBox, you can see them right here. It adds them automatically. Excuse me. Okay, so the second thing we're going to do is we're going to automate two devices in parallel. If you remember, with an iOS, I can't do that on the same computer like I do now, but I can do it using a grid. Okay, so this is the code for automating them. Basically, I just create two drivers. Okay, for that, each Appium instance can handle a single automation session at one time. So for that to work, I need to start 2 Appium instances, which is exactly what I'm going to do. Okay, I'm going to stop this one. And I'm going to start the first Appium instance. The parameters that you see here, the -p and the -bp. The -p is basically the port that Appium listens on, which I give when I connect to the Appium server. This is that, as you can see. And the second one, the bootstrap port, is the port that Android is going to communicate with the device through. It basically just needs to be any high number that's not occupied by another Appium server. So this is the first server that I've ran, and now I'm going to start the second one. Okay, notice that I've chosen a different port and a different bootstrap port. So now we have 2 Appium servers running. And what we're going to do, and hopefully this will work, we're going to run those 2 devices in parallel from the same test. So this is one device, this is the second device. Okay, so the first device starts. And the second device as well. The first device, I write a note on the first device. The famous note. And on the second device, I write the second note, the one that I've written before. So I didn't expect a kind of Spanish Inquisition, and nobody expects the Spanish Inquisition. Then I remove the first note from the first device. And save it. That's it. That's running 2 devices in parallel. Basically, the exact same code that we've done before. The only difference is that I have now 2 drivers that I use, and for each note I just pass the driver that I want to use. So I write the first note with the first driver, second note, second driver, and remove the first note using the first driver. Okay, we have a question. This is a kind of parallelization. Yes, definitely. Currently, this script runs on a single thread, but it automates 2 devices at the same runtime. I could have used multiple threads and run them, properly parallel. Okay, so this was a demonstration of 2 devices. Another demo that I want to show you is a WebView application, a Cordova application. If you remember the desired capabilities from the presentation, you can see the automation name. This is Android. As I said, you have to provide this desired capability for Appium to automate WebView applications. And well, I'll go over the code soon. I'll just start first. I would start the Appium server on a Android mode. Okay, this is how we start an Appium server that's about to automate an app on a Cordova application. You should give it a Android port. Again, some high number that's not occupied yet by another Appium server. Okay, so the Appium server is running, and now we will automate an application. For those of you who know the Cordova Hello World application, this is exactly the application that we're about to automate. Okay, this is the Cordova application. The only thing I've changed is that this is not just green. Once it's clicked, it turns red. So we will see that quite soon. Okay. And once it's clicked again, it will become green. Okay, the reason that it's taking a bit longer than the previous presentation is that I've accidentally ran visual testing in addition to the standard mobile automation. I will show you again. I will show you soon how this works. Just so you know, this is a WebView application. I've also moved to the Appium website. So, you know, it's not just a native application, it's actually a WebView. Okay, so we'll go over the code. This is basically the code that automates the PhoneGap application. The most important thing here, besides the automation name, is this line. Okay, this basically tells Appium to switch into web mode. Once you have a WebView component in your application, it receives some ID, in this case WebView 0, and once you do that switch to, the driver is now in web mode. So it acts as if it was a as if it was automating a web application, standard web application, as if you would automate a browser. So I find an element which has the received class, a P element with the received class, and I click on it. This is the device ready element that you saw flashing in green. After I clicked on it, it became red. I clicked on it again, it became green, and so on. This is a standard web automation code. You would definitely be able to use it on a website that has the same components, so there's no difference. So you can use almost the same code for testing your mobile web application and your actual website if you have a responsive design kind of application. Okay, so that was how you automate WebView applications. And the next thing I want to show you, let me just see if we have time. Okay, so we have a few questions first. If I switch into WebView mode, we get an error of expired Chrome driver version. Do you know about this error? This is kind of weird for me because Chrome driver basically shouldn't be part of the Appium logs. I should probably take a look at the code to see what is the problem. From what I've encountered, the most common problem is that the switch to must have the specific ID of the WebView component. So in our case, it was WebView 0, but it can also be WebView underscore string of some kind. So you need to definitely check it. Okay. Let's see. Another question. There are a lot of sleep statements in the code. Are they a must? I'm asking because when automating tests are executed against Firefox using WebDriver and the action finishes when the page is loaded. Okay. So I'll answer it generally. When you say automating using Firefox, you probably mean the Selenium IDE, which is a specific plugin that uses the Selenium core to automate, and it does wait for certain actions to happen. So when automating with WebDriver or Appium, you basically have you basically might encounter a situation where an action is completed, but the specific screen that you're waiting for hasn't finished loading yet, or specific component hasn't been completely downloaded. So there are a number of ways to handle that. I use sleep simply because it's the easier. Of course, it's the ugliest method to use, but for the purpose of this presentation, it was also the most clear way to show it. You can you have specific waiting conditions as part of the Appium and Selenium interface that can wait for an element to exist using one of the find methods, or for an element to be visible, for example, and you have additional options. For example, if you know that the element is loaded after before another element, you can wait for the second element to be loaded, and then you're sure that the first one was loaded. In short, there are multiple ways that you can approach this problem. The sleep was just like the easiest to go about, but there are definitely more efficient ways to do that. Okay, so I want to show you also, just as an anecdote, that you can automate wearables, the new Android, the new Google framework SDK. This is an emulator for a watch, the LG watch actually. And we're going to run an automation session on that. We're going to use, we're not going to automate WebView now, obviously, since this is a native application. So we're going to go back to the first Appium that we started. And as you can see, you know what? I'll go back. This is the first example that I've shown you. The only difference when automating wearables is just the UDID of the device. Other than that, it's the exact same code. So I basically tell Appium, now I want to automate this device. What you see behind the device, the logs there, these are the Appium server logs running in the Bash console. So, see. As you can see, since this is a standard Android emulator, it responds much slower than the Genymotion emulator. Okay, so now it would install the Notes application, the exact same application that we've seen before, and it's going to do the exact same thing. And it's possible because the wearable is an Android application. It looks like we had some kind of a problem. Oh, okay. So if you take a look at the error that you see here, the element could not be located on the page. Well, there was a difference. The size of the screen for the wearable was much smaller, because it is much smaller. And the element that we were looking for, the new Note element, simply wasn't visible on the screen. So the result was that Appium told us you can't click on this element because it's not available. For that to work, I would have to adjust the resolution of my application to the wearable, of course. Okay, so let's move on. We have not a lot of time left. So, okay, let me just share the other screen. Just a moment. Okay, so let's see. Now we've been through finding elements. You've seen those methods. Okay, so we've ran mobile testing, or have we? What we actually did was automating our application. We haven't actually tested it. The main difference is that automation is basically navigating through your application, and testing is verifying that the elements that are supposed to be in your application are actually there, that they're presented correctly, that they're containing the correct data, that the correct data is saved to the database, and so on. So how do we test an application? Well, there aren't a lot of options when it comes to automating mobile applications. if you want to test them, you have to select the components that you want to test and manually code that validates these components. That is, it validates that they have the correct text, that they have the correct color, etc. And if your application is very complex, this would take a very long time to do and a very long time to maintain. Or the other option is that you wouldn't actually test it. You would select just a few elements and only verify them. This is actually where you have another option, which is visual testing. Just a moment, we have a question. Do we have any tool we can actually create an XPath or a CSS selector and check if it's working? Okay, so there isn't any tool that I'm familiar with outside of Appium. The Appium Inspector, which is available for both for Android and iOS, but it's available, I think, only on Mac, if I'm not mistaken. Has a record kind of option, which can give you the correct XPath for testing elements. Okay, so let's get back to visual validation and why is it important. Basically, as I said, in order to validate elements on your application, you have to manually write code that validates them. Using visual validation can enable you to validate an entire screen with one command, which is what I'm going to show you very, very soon. I'm going to use our tool, of course, for that, which is the Applitools Eyes. These are the main features of, well, these are unique features of Applitools Eyes, well, some of them. Basically, like I said, visual validation can save you a lot of time when validating an application, because in a single instance, you validate the entire elements on the screen. Specifically, I'm using Applitools, not only because I'm part of the company, but because we give maintenance options, automatic maintenance options, which are not available in any other existing visual validation tool. And we have a very intelligent algorithms for automatically resolving problems or identifying false positives, which is a huge problem for the general visual validation field. For example, if you have a different kind of graphics card, your application can render a bit differently, which for the human eye wouldn't look much different, but for a computer it might be like 40% difference in the image, which can be very, very annoying. So Applitools Eyes basically knows to identify these situations and pass the test when necessary. Okay, so I'm just going to show you a demo of visual validation and how it looks like. Okay, so we'll take the standard example that we had, and I just added our SDK to it. This is exactly like adding the Appium client. You can add our SDK. Okay, so what I did was basically create a new eyes object, which, just like the WebDriver is the main gateway for Appium, eyes object is the main gateway for the visual validation part. I used my API key, which is the password for. Okay. Sorry. Okay. I hope now you see what I'm actually trying to present. Okay, so what I wanted to say is this is how you add our SDK to your project. Very similar to how you add it, how you add the Appium driver, and it's the same in every programming language. For example, Python or Ruby, you can use the standard, for example, pip interface to add our SDK. And this is the actual code that does visual validation. So the only thing that I added was the eyes object. Okay, this is like I said, this is our web driver for visual validation. Once we create it, we say we tell it that a test had begun. This is the open command. We tell it which points to check. These are these lines, the check window lines, and we finish the test. And that's it. So I'm going to run Appium again. Okay, cool. It's already running. So I'll run this test, and this time it will include visual validation. So let's see that it's actually running. As you can see, this is the exact same test as before. Oh, sorry, you don't see that for some reason. Just a moment. Okay. I have no idea why we don't see. Okay, so hold on a minute. I will try and have the test visible to you. By the way, I'm getting some hands raised that you don't see the screen. Is everyone seeing the emulator right now? Just a moment. Can you raise your hand if you see the emulator at the moment? Raise your hand if you don't see the emulator. Okay, so unfortunately the screen doesn't, the GoToMeeting software doesn't present my other screen. I will try and just re-show it. Just hold on. Okay, so I think from what I can see that you can see the emulator, which is kind of a shame. Well, you can just take my word for it that what basically happened is for every action, every major action that we did, I took a screenshot using the check window code, the check window command. And once that screenshot was taken, all the elements in the application on that screen were validated. So I have the new note, I have the clear button, the remove note, the save, the text inside the note, the frame. All those elements were validated immediately, which was extremely easy to do. Unfortunately, from what I see, you can't see the code, so again, you'll have to take my word for it. If you have any questions, you can write them now and be happy to answer them. Oh, and one more thing for a moment. We have a poll that we want to run by you. So please answer it quickly. This poll basically was meant to see what kind of additional material would help you with your automation system. So let's say there are additional webinars or video tutorials. Just fill the poll quickly, and we'd be glad to help once we have the results. Okay, 10 more seconds to fill in the poll, and then we'll go into the Q&A. Okay, thank you very much. Okay, now you can see the emulators. So I'll just run the I'll run the visual test again, just so you can see what I was talking about, and it's not just BS. Okay, so I ran the visual validation code, and you would see it right here. So it's basically the exact same test as I mentioned. The only difference is that in key points of the test, I will take a screenshot. For example, once I finish writing the first note, I saved, and now I validated the entire screen. Okay, you don't see that it runs in the background, but all those elements, their location, their color, everything was validated, and now we move on. We move on to the next element, the new node. Okay, and now I validate this. So please note that when I validated this screen, I actually validated not only the position of the elements and everything, I also validated functionality. I validated that the second node was added exactly where it should be beneath the first one, and that the text that should appear appears. So it's not only like a static validation, it's actually can and should be used as a functional validation as well. So with the addition of 3 checkpoint commands, I actually got a very, very cool cover, validation cover for my testing, and which we will see in a minute. Okay, so the Hello Cordova was the first, if you remember, I ran it by mistake. I ran visual validation, and it wasn't, I didn't notice. Okay, so this is the notes list application that we've validated. As you can see, these are the screenshots that we took. Okay, and of course, when validating mobile application, we might have a problem of the clock at the top. So specifically, ApplyTools have kind of a workaround around it. It's not a workaround. Well, you can add dynamic regions in ApplyTools, of course, but more importantly, we have a workaround that even if the wireless network or the clock between steps has changed, so even if this was 5:10 and not 5:05, ApplyTools can automatically add a dynamic region between steps. So I added a dynamic region to this step, and if I go over to the other steps, as you can see, the dynamic region is also there immediately. This is part of the auto maintenance that we provide. And it can be also between tests, between different baselines. We also have an auto-resolve function, which once you approve a specific change, if this change occurred in other steps as well, it will automatically approve them. So if your login panel had shifted right, or your logo has changed, or anything like that, which would cause in a standard visual validation tool for you to go over all the steps and for all the baselines and update it manually, ApplyTools can do that with one shot. It can just, once you click accept, it would automatically accept these changes in all the relevant steps and tests. Okay, I didn't save the test. That really doesn't bother us. So that was that. I can also show you, if you want, visual validation for a WebView application. It's basically exactly the same. Like I said, there's no change. I just do check window, wherever I want to check a screen, and that's it. So I would be happy to take your questions. Okay. How does the validation of the snapshot work? Well, basically there are, okay, do you need a reference image? Well, yes. The first time that you run a test, it automatically saves that test as a baseline. We also have the option not to do that, but this is the default method. And after that, once you run the test next time, it will compare against that baseline. Of course, after you've saved the baseline, the first one or any baseline actually, you can go over to the application, to the Applitools application, and approve it as a baseline. Approve the step. For example, I can say, okay, this is actually the new way it should look like. So I would accept that. Okay, and you can see, by the way, the auto resolve function already worked, because that change was the same change as the next step, so it automatically accepted this step as well. You can see the timeline of the steps here. Okay, I accepted the first step. I said this change is okay, and since this is the only change also in the second step, it automatically accepted it as well. On the third step, there was a major difference, so it did not accept it automatically, and I can say, okay, this shouldn't look like that. It should actually look like this. So I want to reject this screen. I want it to stay as the baseline shows. Okay, and after that, I save the test, and there we go. I have a new baseline. Okay, so we have to mark it. And okay, so once you run a test, if you have a conflict, obviously I can't, at least for the first conflict, I can't decide for you whether it's okay or not. So when I say I mean Applitools. Applitools would know not to treat like minor changes, or at least not a minor change. Applitools would know to treat changes that are not visible to the human eye as non-conflicts. It would not show you a conflict if the, I don't know, if the color had a change in two points, for example, something that wouldn't be visible for the human eye. You can set the match level, but this is the default behavior. But if there was a major change, Applitools can decide which of them can't decide, which of them is the correct state. So you would have to choose whether to accept the new one or reject it. Once you accept or reject the change, if the rest of the steps has an identical change, or at least a very similar change, Applitools will automatically know to either accept or reject them as well based on what you decided, which is what happened exactly a minute ago when I accepted the first step. Okay. Okay, well, we ran out of time, unfortunately. If you have any additional questions, you're more than welcome to send them by email. We'll provide an address to send it to, and I'll be happy to answer it and help you. I hope you had an interesting time, and thank you very much for joining us. Have a good week.